history has always been marked by pivotal events. But very often, their significance only becomes clear after time, decades, or even centuries afterwards. Entire epochs can be named after such events. That's how the Stone Age is remembered as the time when man made his first tools out of rocks. That's followed by the Bronze Age, and so on. So how will future generations remember the time we live in now? Perhaps our current era will be named after one of the most widespread and instrumental organic chemicals of our time. Could this be the Methanol Age? Methanol has many names: carbonol, methyl alcohol, methyl hydrate and methyl hydroxide, to name only three. It's also known as wood alcohol, with the formula CH3OH. It's a light, volatile, colorless and flammable liquid with a very low boiling point, just below 65 degrees Celsius. When purified, it's almost completely odorless. Methanol's great benefit is that it's the perfect solvent, mixing easily with water, most other organic solvents and with fuels. Now is an exciting time for methanol enthusiasts, because the biggest reserve in our solar system has been found on the surface of Saturn's largest moon, Titan. Its rivers and lakes of liquid methane and ethane form bodies of stable liquid, even at minus 180 degrees Celsius. On Earth, methanol occurs naturally in esters, tangerine peel for example. It can also be produced by some bacteria. The chemical industry uses methanol as the base to make other chemicals. A vast array of synthetic plastic materials can be produced using methanol derivatives through processes like polymerization and polycondensation. The word plastic refers to a material's distinctive ability to be shaped and molded under pressure and at high temperatures, and then retain its new solid shape after being cooled down. In just a few decades, plastics and their almost limitless potential to be shaped at will revolutionized the world's industry and economy. That's why the mid-20th century saw a massive plastics boom that changed civilization and touched virtually every aspect of human life. For example, tosalamide formaldehyde resin makes the perfect nail polish. Plastics are quite literally everywhere. Food packaging, wrapping and storage materials, containers of every type and size, hundreds of everyday tools and appliances, in man-made fabrics, paint. The list really is almost endless. There are plastics in our children's toys, the furniture in our homes, and the clothes we wear. There are even traces of methanol in vinyl discs, now back in fashion in the music world. Almost everything we know today is defined by plastics, which are all based on methanol. Annual global production of methanol is almost 60 million tons. That's 6,000 times the weight of the Eiffel Tower. So we can confidently call this world-class industrial development the first methanol revolution, and it's almost impossible to overstate its significance. Then there will be the second methanol revolution. That's just around the corner. We're on the threshold of that momentous event, and it will change the lives of everyone on the planet, and soon. Methanol production starts with extracting the relevant raw material. These days, that's normally natural gas, which consists mainly of methane. One of the most common problems in oil and gas extraction is that hydrates form in pipelines and wells, causing blockages. The strange thing is that the solution is methanol, a product of the gas that creates the problem in the first place. As an effective solvent, the methanol just dissolves the hydrates clogging up the systems, quite literally allowing the industry to clean up its own mess. Methanol is widely used in paints, colorings and varnish. It's used to make the long-lasting pigments and lacquers popular among modern artists. These installations were created by sculptors in Azerbaijan for a large methanol production plant recently opened close to Baku. It also happens to be the first methanol production facility on former Soviet soil for 40 years. The harmony between metal and methanol is impressive, to say the least. Once sulfur compounds are removed from natural gas, methanol production enters its second stage, conversion to synthesis gas. That's usually done with steam, reforming the natural gas with the vapor from the masses of specially treated distilled water. Methanol is widely used in another global industry, agriculture, because of its unique ability to form a variety of useful chemicals. It can be both an insecticide and a fertilizer for plants. One of methanol's many faces is carbamide. Carbamide is more leach resistant than many other fertilizers. The third stage is the actual synthesis of methanol. Once the end product is cooled and collected, the residual gas is reprocessed with a new batch of syngas. Just as green teas are brewed several times to bring out all the useful ferments. Once all impurities are removed by a separate process, methanol undergoes rigorous quality checking, including odor control. Methanol may sometimes contain small traces of a substance that has a distinctive fishy smell. It doesn't affect its useful properties, but may not be very nice for people who have to use it. So this substance also has to be removed. There are several fuel oils which have a similar smell to ethyl, or drinking alcohol. This has caused widespread confusion about the toxicity of methanol. Some have even gone as far as to try drinking methyl alcohol, which is particularly dangerous for your health. Perhaps that's also why there are those who view methanol with suspicion. Let's take a closer look at why. At the very heart of the methanol molecule is a carbon atom, the same one that makes up diamonds. Diamonds may please the eye, but it seldom occurs to anyone to try to eat them. In the Middle Ages, diamond powder was used as a poison. But nobody ever says that the precious gems are toxic. Petrol, on the other hand, is just as toxic as methanol, and few people ever try to drink that. Pure methanol is used as fuel in drag racing, Formula One cars and space engines. Its octane rating is 115. Engines that run on methanol have longer lives compared to those running on regular petrol, and they yield a 20% power increase. What's more, exhaust fumes from a methanol-powered engine are environmentally clean. It would be easy to equip modern gas stations with methanol-injecting systems. Methanol mixes well with petrol in any proportion, boosting the octane number and, consequently, fuel performance. All these are remarkable properties, reason enough to believe that the future of the global energy industry is methanol. Considering that traditional energy resources are fast running out, it can only be a matter of time before the second methanol revolution. And here's one extra curious methanol fact. It's also produced, in very small quantities, by the human body. So in a sense, everyone has their own personal 24-hour methanol production facility.